The beginning of April also brought about the beginning of a whole new phase for ESA's Jupiter Icy Moons Explorer mission, Juice. After years of development, the spacecraft has now been fully integrated and sent to an Airbus Defence and Space facility in Toulouse, France, for the next round of testing. An important milestone in the spacecraft's development, leading it towards launch 1 year from now.
This milestone is very important because here we have the spacecraft. It's integrated, it's ready. We have all the 10 instruments are delivered, are there. All the platform units are there, the antennas is all in place. So the spacecraft is ready for the test campaign to verify finally that everything's work as expected within the performances they are expecting. And this 1 year from launch.
Although there are contributions from the American Space Agency NASA and the Japanese agency JAXA, Juice is primarily a European mission, and many of the 10 instruments were developed by the national space agencies within ESA's member states, such as Italy, Germany, France, the United Kingdom, Sweden, and many others. With 10 different instruments on board, Juice will carry the most powerful scientific payload ever flown to the outer solar system. And so for European industry in general, and prime contractor Airbus Defence and Space in particular, the complexity and scope of the mission proved to be a worthy challenge. Now, with the testing of the spacecraft in flight configuration going well, it seems their hard work has paid off. An important achievement for European industry.
In fact, on Juice, we collect a number of design and performance requirements for which it is not taken individually the first time that we face them on a spacecraft, but we have all of them at the same time on this mission. And it's a bit particular that we have to face all these design requirements at the same time. And in addition to that, we have also some requirements coming from the environment itself of Jupiter, like temperature and radiation. Jupiter is a very aggressive radiation environment that is making the whole design of a spacecraft even more complex.
Juice will fly to Jupiter to study the massive gas giant and 3 of its planet-sized moons, Europa, Ganymede and Callisto. The spacecraft will do several flybys of Europa and Callisto before going into orbit around Ganymede for a more in-depth analysis. It will be the first time a spacecraft will orbit an outer solar system moon, and it will teach us much about the frozen worlds of Jupiter's moons. By studying the Jupiter system as an archetype for gas giants across the universe, scientists hope to address 2 core themes of ESA's Cosmic Vision program. How does the solar system work, and what are the conditions for planet formation and the emergence of life? Tantalizing questions humanity has struggled with for centuries.
The scientific objectives of Juice are multiple. So first of all, humanity always poses itself a question, are we alone in the universe? Is there life outside Earth? To respond to this question, first we need to answer to another question. Are environments where life can be sustained before going and search for life? And this is one of the main objectives for Juice, to search if on the environment, on the ocean world of Europa and Ganymede, there are the conditions to sustain life. The other objective of Juice is to study the Jupiter system in its integrality, as seen as a miniaturized solar system.
The expectations rise as the countdown to Juice's launch in April 2023 has started. Now the satellite will be further tested in the following 9 months before it's shipped to Europe's Spaceport in Kourou for its launch on top of an Ariane 5. After launch, the spacecraft will need an 8-year journey, performing a few slingshot maneuvers along the way to reach the Jovian system. Then it's estimated to perform its explorations over a nominal 4-year period. With Juice, we will learn much about the universe and solar system we inhabit, and perhaps even shine a brighter light on the question, is there other life out there, or are we alone?